All right, welcome back, folks. Let's get going. If you are still eating lunch, totally good. Just enjoy your lunch while we jump into the next section. I'm going to go ahead and share my screen, and I will be covering a section now on continuous delivery, where we will cover the approach of taking the work that we did in the previous lab, where we got the application running locally inside of our Cloud9 environment, and we're going to recreate that through a pipeline that's going to deploy it into the shared cluster. Before I jump in, I do want to just open it up. Did anybody have any questions or any clarification they need after completing that previous lab? Okay, then let's get going. So our goal with this next step will be to create a continuous delivery pipeline. We're going to be using Jenkins to build and deploy the application into the shared EKS cluster. So you'll all be targeting the same cluster, but you'll be running in different namespaces. Now, there's a few things that have to happen. One is everyone's going to get your own Jenkins instance. So the way in which the Jenkins environment is provisioned is through this SDM through Sparky. So you're going to be making requests of Sparky to provision a new Jenkins instance. The Jenkins instance will be running in the Kubernetes cluster in its own namespace. And then that Jenkins instance will have access to deploy to some other namespaces that are also provisioned for you in the same cluster. So at the end of the day, what we're just trying to do is get the application that you built in the first section to be exposed through a Istio gateway and deployed and running in the shared cluster. So let's talk about Jenkins first. Jenkins provides many things to many people. In this application, we're going to be using it as our CI/CD pipeline. We're going to be using the Jenkins Pipelines construct to describe pipeline for this first application. The pipeline will have a pretty simple workflow that looks like this up top here. There's a build stage where we're going to run scaffold build, just like you ran scaffold locally inside Cloud9. We're going to have a deploy stage where you run scaffold deploy, which will then just call Helm install for us. There'll be a manual gate where you can manually approve the deployment to production, and then there'll be a production stage that uses the same Helm chart, the same images, but instead pushes up to a different namespace, a production namespace. And so just to review, in case you don't have experience with Jenkins, the way the Jenkins pipelines are created are through a file called Jenkins file. So you create this Jenkins file in your repository, and then Jenkins will read this file and use the declarations inside it to describe what type of pipeline it should run. So what we're looking at here is a very high-level overview of a simple pipeline. The one pipeline has two stages: build stage, deploy stage. And then there's a set of steps that you would put inside the stage. So let's take a look at the details of what we're going to end up building in this next lab. We're going to create a build stage. And in the build stage, there's a few things that I want to call out. There will be an agent block in the build stage. And what the agent blocker is responsible for is describing what Kubernetes pod template to use to run that stage in. So you can configure Jenkins to run different stages in different Kubernetes pods. And the benefit with that is then you can have different builder images that have the appropriate tools predefined. If you've worked with Jenkins before and you've dealt with the pain of managing plugins and managing tools across all of your worker nodes inside the Jenkins environment, you'll appreciate that can be painful. And this is a nice approach to avoid that pain by having a prepackaged image with all the right tools in it. So in this case, we're going to use a agent that has scaffold and Helm installed in it. And then you'll see the steps. We're going to run these steps in the scaffold container that's in that pod template. And we're going to just run scaffold build. This scaffold build looks very similar to the scaffold build command you ran as part of the previous lab, except you'll see we're passing this file output flag. And that's because what happens is scaffold determines what to use for the Docker image tag. It creates a unique image tag for you. We need to keep track of that so that we can feed it into subsequent steps to do the deployment. And those subsequent steps will be running in different pods. And so what we then do is take that image.json file that has the coordinates of that Docker image, and we stash it. Stash is a construct of Jenkins pipelines where you can stash a file. That file can then be unstashed in subsequent stages. So we grab this file, stash it, and then if we jump over to the deploy stage, you'll see that over here, we unstash that file and then pass it in to the scaffold deploy command. So scaffold deploy looks very familiar to what you were using previously in your local environment. Scaffold deploy here is using the image JSON to target an environment. And what we do is we pass in environment variables for you into your Jenkins instance that was created so that you can target the appropriate namespace that was created for your Jenkins environment. What else do I want to call?
I have a question.
Yeah.
This agent, the lead toolchain scaffold, I imagine also contains a Jenkins software there, right? It's just a Jenkins with additional software that you need to deploy there. Is that correct?
Not exactly. So lead toolchain scaffold, we can take a little detour right here. So these are all our builder images are open sourced. And so like each of these subdirectories represents the image that we're using. So you'll see there's a builder image scaffold. If you go into there and look at the Docker file, there's nothing about Jenkins in here.
Okay.
This Docker image only has it starts with the Docker base image. It installs scaffold, and installs container structure test, kubectl, and Helm. These are just some tools.
Okay.
That's it. Yeah. So what happens is your pod template, this agent becomes when this stage runs, the Docker master, the Jenkins master will reach back into Kubernetes and launch a new pod. The pod spec is captured in a configuration with this name. The pod spec will end up with two containers in it. One container is the one I just showed you that has the tools. There's another container that gets attached, kind of like a sidecar container, that runs the JNLP process. That JNLP process is what a Jenkins slave typically runs that talks back to the master.
Okay, got it now. Yes, yeah. Yes.
Yeah. So what's cool is every run of your pipeline creates a whole new pod, which keeps it immutable and ensures that there's no drift with those environments. All right, good question though. Okay. Another important step is there's a manual step that we're going to put in the pipeline. A few things to call out here is, first of all, we only do this on the master branch because for non-master branches, we're not needing to promote to the higher environments. So we're going to skip this for the other branches. Another thing that's good to point out is that we use agent of none. And the reason why is when you use an agent, again, that turns into pods running in your cluster. A manual step could take hours or even days to complete. And so there's no reason to run a pod for that period of time that's doing nothing but sitting there idle. So we want to set the agent to none, which means that it ends up running on the master, which is fine because there's really nothing happening here other than it's blocking, waiting for somebody to click the approve button. And then there's one last piece here that's important, and that is how do we get events out of Jenkins? So our Jenkins job is running, and what we really want to do is capture the activity that's happening in Jenkins and send it back into our Slack environment so that we can see updates as our build runs. Well, what we did here is we created a plugin, and that's also open sourced here. The link is available here. This plugin, pipeline status plugin, is responsible for capturing events inside the pipeline run and then turning those into Kubernetes custom resources and events on those custom resources. So you end up with every single stage start and end event ends up being an event inside your Kubernetes cluster. And then we're able to scrape those events and send those in as Slack messages. So it's a nice way to provide integration between the legacy Jenkins environment and the Kubernetes environment. And so then what you end up with, there's some nice messages like this. We see that a build is running, and we see that who performed the build, what the message was on the commit that triggered the build, and the progress as the build progresses. So you'll get a chance to see this in a little bit when you get into to this part of the lab. All right, so the next thing we have to talk about is Service Mesh, specifically Istio. So when you deployed your application previously to the Cloud9 environment, you created a service, and then you did a port forward on the service so that you could get into the application to validate that it was working. That's not going to work in a production environment. We can't just do port forwards into the environment. So we need to find a way to get an ingress of some sort into the cluster. Now we could just use ingress. You have a couple options. You can just use a service of type load balancer. That'd be an option, but it's not an approach that will scale and solve some of the other problems we have down the road with going to microservices. You could create ingresses, which are another form of Kubernetes resources, but those also have scaling issues and don't solve some of the problems that we're going to have. So what we're going to do here is we're going to start using Istio in this lab, and it won't provide much for us other than provide an ingress into the service. But I want to talk about Istio a little bit because it will provide value for us in some of the subsequent labs, specifically microservices and the deployments and observability, all the ones after this one. So Istio is an open source project created by Google, and I think if I heard right, is being donated to CNCF. Can anybody confirm that for me? I thought that came out just like a week or two ago. Did anybody else hear that? No. Okay. Maybe I'm hallucinating. Someone fact check me on that. Might have been a dream. So what the Service Mesh offers is there's really these four capabilities that you're looking at for Service Mesh. So the first is connect. It provides a mechanism for various services inside the mesh to talk to each other. Excuse me. So service A, let's look at this picture actually. So what we see is we've got these two pods and services running inside our cluster. And what happens with Istio is the first thing it does is it introduces a sidecar into every pod. And that sidecar consists of an envoy proxy. And so what happens is now when service A wants to talk to service B, rather than talking directly to each other, service A has a rewrite so that it routes instead to the local proxy. The proxy then looks up the appropriate location to send the traffic to through the control plane that is Istio, and then communicates with the corresponding envoy proxy that's a sidecar for the services trying to communicate with. Now you might look at this and think, okay, this is adding a whole bunch of complexity. Why did we just do this? Why don't we just let service A talk to service B? And that's a fair question. I mean, if you're just looking to have communication flow, you could do something as simple as DNS, or you could introduce something a little bit more intelligent like console for service discovery. But what you'll see in some of these other things beyond connect is that that's where the value really starts to shine with Istio. So the next thing that's important to understand is the concept of being able to secure communication from service A to service B. So by flowing the traffic through these envoy proxies, you're able to now do mutual TLS between service A and service B, authentication through TLS certificates. Because what happens is Istio will handle the creation of certificates in this module called Citadel. And Citadel generates the TLS certificate, signs it with its own local CA, and then the proxies can authenticate the request through mutual TLS. So service B can, by verifying the TLS client cert, that this request is in fact coming from service A. So service A and service B, the developers there don't need to figure out how to do mutual TLS. As a matter of fact, they don't even need to know it's a part of the conversation. It's introduced through the mesh. And then some other things that then become valuable is the ability to control the flow of traffic. So I can say, hey, service A is allowed to talk to service B, but not the other way around. Service B can't talk to service A. So you're able to enforce those as policies based on the authentication that you establish through mutual TLS. And you can even go a step beyond that and not just authenticate and authorize, but also introduce things like rate limiting, where I could say service A can talk to service B, but it will be restricted to no more than 10 requests per second. And that way, if service A introduces some major change to the way their application works, or if there's some sort of a defect or unplanned load, it will not bring down service B or other consumers of service B. So you're able to offer service levels at that with that type of capability. And then the last thing is you increase your ability to introduce observability, because the mesh is able to collect all these metrics about traffic that's flowing through it, stored in Prometheus, and then you can peel metrics out of there to understand what your traffic looks like. And we'll get to play with all that in a little bit. That's as much as I want to get into with Istio for now. Just know that we're going to start using it. Specifically, two features that we need to cover. One is this idea of gateways. So an Istio gateway is a custom resource that is defined. We're only using ingress gateways, public ingress gateways. So we're going to have an ingress gateway that is receiving traffic from the public internet and is then performing routing logic to route the traffic to the appropriate downstream service. A gateway looks a little bit, is defined as YAML like everything else. And you can include various listeners that you want on the gateway. So in this case, we're listening on, for this specific host name for HTTP traffic. And the ingress is configured to redirect to the HTTPS port, which is defined here. Now we've got an HTTPS port that uses a secret named myapp-credential for the private key material for the TLS termination from the public internet. So this gateway is just responsible for being the edge of the mesh where traffic from outside the mesh can come in. And then if we take a look, we then need to define these things called virtual services. So the gateway is just receiving traffic from the internet. And then a virtual service is responsible for determining where to route the traffic, what real service to use based on information in the request. So in this case, we just have a default route that says all traffic goes to this Spring Trader service, which is what you defined in the previous lab. Okay, one last thing that we need to talk about, and then I'm going to cut you loose for this next lab where you're going to create your own Jenkins environment and your own Jenkins pipeline. And that is, we're going to use Sparky to create our pipelines. And so once you have your Jenkins file created and you push that code up to your GitHub repo, you're going to go ahead and run Sparky add, and then you're going to give it the repo name. So like in my case, it would be Sparky add cplee, because that's my GitHub handle / SpringTrader. When I run that command, Sparky then goes through and performs a series of tasks to create what you see down here. So when you do the Sparky add command, we have a controller that creates a new custom resource. And then there's an operator that runs Terraform inside the cluster. And that Terraform is going to create 3 new namespaces for you. It's going to create a toolchain namespace where Jenkins is then deployed into. It's going to create a staging namespace, which is where you can deploy your application for the staging and testing. And then it'll create a production deployment where you can deploy for production consumption. And then the operator also handles configuring any plugins that need to run inside Jenkins, and also configure your job itself inside that your own Jenkins environment. So you're going to be using Sparky, and then you'll be able to get in and look at the Jenkins job run, and you'll see the results hitting you up in Slack. So that brings us to this next lab. I'm going to go ahead and drop this link into the general channel. Lab 2. So go ahead, jump into that lab and start going through it at your own pace. If you have questions, just holler. And if you have, I'm happy to answer any questions now on any of the material we just covered. But otherwise, go ahead and feel free to get started on the lab.